Welcome back. My name's Rob and I'm a mineral prospector. On the last presentation I did, we talked about the assay ton system, what it was, and the calculations behind it. I get a lot of requests, questions asked regarding analyses out in the field, and these requests usually come from the small placer miners or the small hard rock operations. This presentation, I'd like to answer some of those questions. So what I'm going to look at is screen analysis. Now out in the field, you're probably using screens like this to concentrate the material that you're digging, to make it a suitable size to run through your sluice box. And from the sluice box, the concentrated material, you're either panning it out, running it through a shaker table, or even a miller table to extract those fine, minute particles of gold. Now those screens can also tell a story. They can be used for analysis. So what are your screens telling you? Let's explore that a little bit further. The screens on the right are the ones you're probably most familiar with. They're of different mesh sizes and they're used to concentrate the material that you're mining. But they can tell you a different story. They can tell you approximately or estimate the amount of gold that you're going to get out of the area that you're mining. The diagram on the right-hand side is a representation of those screens. On the very top screen, you'll see you have some material inside the screen. Any material that's left inside the screen is referred to as metallics. The stuff that falls through the screen right down to the very bottom pan is known as pulp. So as you can see in this diagram, each screen has metallics in it. The very bottom one is the pulp. Okay, now that we've covered a little bit of the definitions, let's take a look at a scenario. Let's say at your dig site, you've gone down a little ways. You've collected a 5-gallon bucket of this material that you're mining, that you want to process, but you want to find out how much gold that you can expect from this particular location or dig. Let's say we got 3 screens and you have your gold pan. And the first screen is your 100 mesh. Second screen maybe a 120 mesh, and third screen a 140 mesh. So you take your bucket and you take a scale and you weigh out approximately 2,500 grams of material. Let's round it off to 2,500. This is just a scenario for calculation. And let's say you ran that 2,400 grams through your 100 mesh screen. And on that screen, you ended up with 10 grams of metallic. And in your gold pan, you ended up with 2,490 grams of pulp that you set aside, put it to one side. Now, you took your 10 grams and you crushed that down one way or another, and you panned that out, and you weighed out 2.14 grams of gold at the end when you cleaned out your gold pan. Well, this is the scenario that we're going to use. So let's explore a little bit further. Okay, now you've processed the 2,500 grams through the first 100 mesh screen. You ended up with the 10 grams of metallic, gave you 2.14 grams of gold. But it took you a long time to hand process that 2,500 grams. You don't want to do that. You want to cut your time down. So you decide you're going to take 800 grams of that leftover material and you're going to run it through the second screen. Here's what a lot of people don't understand or don't realize. You're only taking 800 grams from that 2,490 grams that was left over. That makes it 1,690 grams that's unaccounted for. So you run that 800 grams through, you get 1.8 grams of metallic on your second screen. Now you're going to have to estimate the amount that you would have, the total amount in that screen if you used the full 2,490 grams of pulp. You can do this easy. You take that 2,490 grams that you had left over from the first screen, you divide that by the 800 grams that you've taken, and then you times that by the 1.8 grams that was left on that second screen. That'll give you an estimated amount of 5.60 grams of metallic that you would have had on that screen if you used the full 2,490 grams of pulp. Then from that, you can actually estimate the amount of grams that you would have had in gold if you used the full 2,490 grams of pulp. You can do this by taking the analyzed amount of grams that you have, the 0.13 grams of gold, divide that by the 1.8 grams of metallic, times the total metallic of 5.0625. That gives you 0.404625 grams of gold that you would have had on that screen. You need to record that amount of gold. Okay, now you know the amount of gold that you have and the amount of material, metallics you had on your 120 mesh screen. But now you've got that 1,682 grams of pulp left over. And of course, you decide you're not going to run the whole entire 682 grams through your third screen, the 140 mesh screen, because you know that the smaller the screen size, the longer it's going to take to run that through. So you decide you're going to take 400 grams of that material, and you've weighed it. And you end up with 2.8 grams of metallic on that 140 mesh screen. Of course, you analyze that, you pan that out, and you end up with 0.27 grams of gold. But what do you really have? Well, like the first screen, the 140 mesh screen of metallic, you started out with 249 grams. Then you minus the 5.6025 grams. You divide that by the 400 grams that you've just run through your third screen, and times that by the 2.8 grams that you have on metallic of that 140 mesh screen. That'll give you the estimated amount of weight that you would have had on that 140 mesh screen. That works out to 17.39 grams of metallic. Likewise, you can now find out or estimate what the gold amount would have been if you used that remaining 1,682 grams. And that's easily done. You take the 0.27 grams of gold that you've analyzed and weighed. You divide that by your 2.8 metallics left on the screen, and you times that by the 17.39 grams of total metallic. That gives you a total amount of gold estimated at 1.676983 some odd grams of gold. You want to record that figure. Okay, now you've run all that material through, and all that material is sitting on the bottom pan. 392.7 grams in total. You took that material, you ran it through your sluice, micro sluice, or you panned it out, or you ran it through a miller table. In any case, you analyzed that pan as having 3.23 grams of gold on it. So how much gold do we really have in that one pan? All the rest of the stuff we didn't use is unaccounted for, but it still has to be estimated. Well, that's easily said and done because you started out with 2,500 grams. You turn around, you minus the 5.602 grams of metallic that you had on that first screen total, and then you minus the total of the 17.39 grams that you had on the 140 mesh screen. That total you divided by the 392.7 grams of pulp. Then, in order to estimate the amount of gold that would have been in that pan, you times that by the amount of gold that you analyze, the 3.23 grams, and you end up with 20.0615 grams of gold. You record that amount as well. Okay, now that you got your final down to your final calculations, we're going to go back and we're going to use that assay ton system. We know what our total gold is now. We got the 2.14 grams off the very first screen. We estimated the amount of grams that you would have had at 0.0462 grams, etc. We have the estimated amount of grams on the next screen, the third screen, at 1.6769 grams and so on. And we also have the 20 grams estimated from the pan at the bottom. Well, when you add that all up, you end up with 24.28 grams of gold estimated. Now we got to turn around and we got to change that into milligrams. So we times that by 1,000, of course, and we end up with 24,280 milligrams of gold estimated from that 2,500 grams sample. Well, in order to work out the amount of ounces per ton in that dirt that you're digging, you take your 24,280 milligrams and you divide that by the assay ton system. In this case, it's the 2,500 grams that you started with, divided by the magic number, 29.166, and you eventually end up with a troy ounce per ton. That works out to 0.28 ounces, troy ounces that is, per 2,000 pounds. That's not a lot. Now you may want to figure out what is that per gram in metric tons. Well, to work out the grams, you just simply take your 0.28 grams, times that by the magic number of 34.286, and what you end up with is 9.7 grams per ton gold. Now, if you're using mechanical equipment like trommels, crushers, pulverizer, and then you run that through a shaker table, and then follow that with a miller table, and then collect your gold at the end in little glass jars or collection facilities. If you're running a lot of tonnage, 9.7 grams is not bad. But if you're doing this by hand and you're shoveling a ton of dirt through your sluice box without crushing it, without concentrating it, and just allowing your sluice to concentrate, I don't know if you want to go through a lot of time and effort to come up with 9.7 grams at the end of the day. In any case, this is how you can use your screens to calculate what you're going to expect or estimate from that hole that you're actually digging. This presentation was basically geared to the small placer miner or the small hard rock miner. The subject matter was on analysis using your concentration screens to estimate the amount of gold that you can expect from your digs. With that information, you can pretty well decide whether you want to continue digging in that spot or basically move on. Now, if you find this presentation interesting and useful, please give it a big thumbs up. My channel is not designed for any promotional sales of any type. It is strictly educational. Most people out there, they talk about showing you how to pan for the gold, how to search for the gold, but they don't really discuss the dirty ins and outs of estimating your gold values. If you're a prospector like me and you're looking for material that you can promote, you might want to promote your claim to a larger uh, mining company, or you may be looking at selling your claim. You're going to need to know a lot of information, and basically you have to prove the claim before you sell it to give it any credibility. And this is one method and one tool that you can use to do so. Like I said, thank you for watching. If you do find this presentation useful, please give it a big thumbs up. Until next time, I might start talking about what fire assay is all about. So, catch you on the next presentation.